A very warm good evening to everyone. I, Dev Khanduja.
And I, Pratik Gupta, cordially welcomes you all to this enthralling talk on machine learning, which we are organizing as a part of Robo Week, presented to you by Robotics Society and ITM Irma.
We are pleased to have Mr. Harish Kashyap sir with us. Harish sir is a visionary who currently works as a machine learning scientist at Path Robotics. He has worked at various research labs and industries such as Nokia and Amazon Robotics. He has a master's from Northeastern University, Boston, in electrical engineering.
He has several publications and patents filed in the name of ML. He has led various data analytics projects across US and Europe. He is also the AI Developer Advisory Board Manager at Microsoft. When he is not working, you can find him indulged in art and archery.
Harish sir, we warmly welcome you to our Robo Week. We request you to take over the mic from here.
Hi everyone. Nice to meet you all. It's a good initiative. Thanks to
Likewise.
Pratik and thanks to Taranam for inviting me. I think this is a great way to talk to people who are in a field that you might want to get towards and understand and see if these talks can spark an interest and provide some clarity in what you're trying to do. So the talk today that I'm going to give is going to be tailored specifically to the community in terms of giving clarity on certain areas where you might have questions already. And these are not only for students, but also for the community at large. And the idea here is if this talk can provide you some clarity on your future visions and also form visions, as well as your path towards progressing in this field, then you can leverage from it. You can always reach out to me later too. So let me present my screen. So machine learning in robotics. So let's talk about the history. The traditional robots involved programmable devices inserted into hardware to perform certain specified actions. So they were essentially rule-based, which means that the real world is really complex. And if you have rule-based systems, they do not always work because the noise that exists in the real world is really complex. And also the perception is not easy. To match the human levels of perception is a humongous task in itself. And so the robots really got confined to the research labs and not really into the real world as much as we see today, or it is getting to where it is today. So what was it that led to the penetration of robotics, and also what does the future look like? So the real world, it was limited by algorithms and software as well as hardware. So computing power was weak. It was not as high as we see these days with the GPUs being available, making it easier for production-ready software that can make an impact in the real world. So AI was introduced in robots as early as 2000, but the advancement in AI had not progressed to levels that we see today with the deep learning and many other methods that are able to not only match, but also beat human levels. So they could not really make it to the research lab, from the research lab to the industry because of the levels of accuracies. So in advancement, it means that it needs a breakthrough in technology. So if you have to bring it to production from research, you need to be able to match the requirements of the real world, which means that you should be able to solve problems in real world, not just theorize them in terms of mathematics or in terms of theory. So the control theory, which is now absorbed into AI, for example, they were always traditionally used in missiles. They're still used in defense, tracking systems, and other areas, signal processing methods as well. But all these methods that have been used traditionally were limited to certain domains. Now that the AI as a field is coming up, there are more people getting into this area. And so which means that there are more people who are studying areas that were not traditionally being looked into. And which means that the impact of these areas into production are going to be huge in the coming years. So what are the several areas of robotics? There are many areas. So the main areas that we should be looking at are perception, which means that if you have a camera, camera is one way to perceive the real world. Can you perceive the real world through these cameras or other sensors? and then make a decision based on the information that you gather. The other is localization and mapping, called SLAM, that you might already be aware of, which means Kalman filters, particle filters. So the Kalman filters and particle filters have already existed in theory for decades, actually. And these have been studied and being deployed. But again, as I said, they were always confined to mostly research labs or to certain specific areas in production, but limited areas. Reinforcement learning, control theory, signal processing, and machine learning. So we are looking at robotics that not just compasses one area, but also compasses many areas, and mechanical engineering as well, which is a non-trivial part of it. For example, if you're looking at a touch sensor, how do you invent a new touch sensor? It gets into chemical engineering, mechanical engineering. So it's an area that touches many different areas of engineering, mathematics, and as well as the research and production. So why now? Why are we talking about it now? Why what about AI and robotics? Like, what's the big deal about it? Why not in the last many years? Why only in the last few years? What enabled the transformation? So the background is, what AI does is to add intelligence to rule-based robots. So if you have rule-based robots, let's say you have a robot that just looks and does certain specific task. For example, a robot that just cleans your house and picks up the dust. All it has to do is look for certain rules, and it can do a fairly decent task, and those can be deployed to production. But what if there is a cat in the room? What if it navigates and then tries to attack the robot? How do you deal with that? So these are certain situations where it requires certain intelligence to work through the real world, because the real world is really complex and not just based on rules. They're based on certain sophisticated rules that come from something we call intelligence. So as I said, now the pioneering work was already done by many labs, such as Microsoft Research, IBM, Merle, BBN, Bell Labs. These are some very famous research labs that did some amazing work earlier in AI. But still, it had not penetrated to the large scale as we see until 2010. So what sparked the interest? There are many reasons given to why the interest got spiked up. One of the main reasons, I think, is due to the Netflix challenge. The Netflix challenge was a $1 million challenge put up public for people or engineers who could actually improve their movie recommendation. Why was it important? Because it's because of the user engagement. If you think about it, how much time do you spend on either Amazon Prime or Netflix to actually select a movie? Sometimes you spend more time than watching the movie itself. So, which means that if you could improve the movie recommendation system, the user engagement improves and people are hooked onto their platform, which means that the platform can make millions of dollars, and it could basically not only have millions but also multi-million-dollar impacts out of a proper movie recommendation system. So for this challenge, a team of statisticians, engineers, they all came up with an ensemble model. What an ensemble model is that you basically take sets of models that perform well on certain areas of the data sets, and then you combine them to get an overall improvement in the accuracy. So this model was eventually discarded. It never really made into production, is what we've heard, but it did provoke a large interest in data science to begin with, because the people who actually solved this were called data scientists. And then data scientists usually use machine learning models to bring things to production. So it did spark an interest in machine learning and AI at large. So then the data science became a big field. People started learning data science. Data scientists started getting hired because what the companies found was that the impact of data science, so just applied certain areas of machine learning or statistics into their existing data sets, could reveal information that they would traditionally not know about. For example, they wouldn't know what to do with their data until and unless you had a data scientist to look into it, or a machine learning scientist to look into it. I'll explain the differences later. So once you look at the data and harness the data, you could get inferences from it. For example, let's say you have a travel data set. You have a travel data set that tells you that person always goes to a certain tourist area and then visits another area next. And there's a certain tourist area that's never visited in tradition. Then you could go to the city council and explain to them that this particular attraction, point of interest, is not getting it enough attention because of many reasons. And it's for whatever it is, you need to improve that particular attraction and create interest so that people can visit this attraction. So simple analytics, not even predictions, not even intelligence, just an analytics based on the data was not existent as much as we see today. And this is a classical challenge, and it's non-trivial, because the difference between what is a classical challenge is a classic challenge between identifying what is data science, what is machine learning, and what is AI. That's a challenge for even large firms. They've not really got it right. Only few firms have really got it well. So even to this day, you'll see many job descriptions that say data science, but then they're looking for machine learning people. Or you see machine learning scientists or research positions where they're really hiring data analysts or data scientists. And so how do we define this? Like, how do we bring about a boundary between data science, machine learning, and AI? So the general trends I'm going to talk about, these are not exceptions. There are a few exceptions, and I do believe the exceptions exist because they've just not figured it out, because their leaders themselves might not be the perfect people for their job. And so, for example, data scientists do not always know how these models work, but they know their impact. For example, they might be limited to knowledge of linear regression, L1 and L2 scores and things like that. They may not know anything beyond that. They may not be able to explain filters, particle filters, for example, how the inverse methods work, or an example on how convolutions work. So getting into a deeper mathematics might not be their field or of their interest, but they might be very good in applying certain methods and getting results out of them without actually knowing how they internally work. So these are called data scientists in general. And it doesn't really require sophisticated coding as well. It's limited to Python data frames in few areas. So people from statistics backgrounds, physics, economics, or even some computer science backgrounds who do not have too much of mathematics knowledge or interest could also get into these fields because they could essentially apply existing methods. They don't need to know all the time how they actually work, but they need to know, if they know what exactly it produces, they should be able to solve some of these problems to some extent. What is machine learning? The machine learning people are usually the people who come from classic research background in machine learning, who've published a thesis in it, who've worked with pattern recognition in the electrical engineering world. And these are usually computer science or electrical engineering people with math degrees. It doesn't limit them people to only these degrees. You could come from mechanical areas, you could come from other areas. As long as you have the required courses, you should be good, or even statistics, for example. And the people who are researchers, they should have either invented or be capable to invent new methods in machine learning. And AI, what is AI? AI basically is a collection of all methods. It's a collection of signal processing methods, control theory methods, machine learning, and data science, which is, by data science, what I mean is that you look at the statistics part of it. And what's the difference between research and applied scientists? Research scientists basically limit themselves to advancing the field and do not really worry about its implementation and production. Again, this doesn't mean that research scientists are not capable to do it in production, but their interest is primarily in advancing the field. The applied scientists go beyond research scientists. They are not only capable of doing the research and advancing them, but also spend a significant amount of time in actually applying them in production, which means they know how to deploy them and solve real problems, and also go back and invent. So these are mostly the applied scientists. They're the ones who create the impact that we see. So the interest in AI, I mean, traditionally, what was the formative point at which AI became a big deal, and leading to robotics becoming a big deal? So the traditional methods in speech recognition, they had hit a plateau with accuracies in the 80s. This is for English. And people who did research in those days could hardly advance the accuracy by maybe a 2% or a 1% or maybe 0.5%. These are still significant. We're still significant because you're looking at millions and millions of data sets. So 0.5% of these millions means that the improvement could be in several areas of speech, which are non-trivial. However, the deep learning methods, once they came from the speech world, they increased the traditional accuracies above 10%. And that became a big deal because none of the methods earlier could actually increase accuracies to those levels. And this happened because the computing power was available, than what was earlier. They're much more computing power in terms of GPUs, as well as, so you could base the software as well. So you could increase the number of levels in a network, or the degrees of freedom in the network, to learn more randomness in the real world than that we see today, than that we actually was seen earlier. And these methods were generalized to computer vision and image processing and many other areas. So deep learning basically encompassed into speech, text, analytics, and many other areas. And this sparked a new interest. And why was that? It was because you could not only meet the human levels, you could beat the human levels of interaction. An example is Alexa and Siri. I mean, they happened only, major reason would be deep learning. Deep learning could essentially enable the levels of accuracies that we've not historically seen, and that could actually meet certain areas of human recognition and beat. Do they do in all areas? No, not really. We're not there yet. But in certain areas, they can. For example, Alexa can understand to a large extent. And robotics saw a new high because if you look at computer vision methods, this enabled autonomous navigation. So autonomous navigation is really possible because you can see the autonomous vehicle can be thought of as a robot, essentially, which can actually see, perceive, and even meet human levels of recognition. Can it solve all problems? Will it always beat humans? Not necessarily. But can it really meet and beat humans' levels of accuracies in certain areas? Absolutely. So robotics saw a new high because robotics is usually a collection of all these methods as applied to the real world in using a hardware. And that is why this became a big deal, because robots that were involving all these methods became intelligent. Those that were not so intelligent became very intelligent. And how do we know they beat human levels? This might be a question to all of you. Like, how do we know? There are multiple ways to measure this. The basic method, or a very common way to measure the accuracies, is you have multiple humans doing the same task, and you measure how many times they go wrong. And then you also have the AI models that can do the same task and see how many times the AI models can go wrong. If your AI can beat those numbers, that means you can say that they're definitely better. So what does this mean to robotics? This means robots can see better objects than humans can see. If you have, for example, if you have the vision built into them, like for example, self-driving cars. I don't know how many of you saw this. Recently, a Tesla could avoid a crash that was not easy to recognize by a human. It was a fast approaching vehicle at a very, very high speed, and the idea was, how do you recognize this, that it is indeed a risk? And not that a good human could not recognize, but the fact that an autonomous vehicle can do that is a big deal. They can listen as well, and they can also learn better with new data. For example, if you can train a robot to do a certain task, they can get better as they learn with newer and newer data coming along. So what are the applications of AI and robots? Are robots just moving humans just like objects, or what are robots in general? I mean, robotics in general is not limited to just the way we can think of, which are traditional objects that resemble humans. We can look at robots in surgery. This again is important because the levels of precision are very important, where you cannot really miss. And if we can reach those levels of precision, you can use robotics in surgery. In warehouses where you have shipping, or you have many other industrial automation processes, you could use robots to automate these processes. So as long as you're using sensors, hardware, and AI software to interact with them, then you're very likely solving robotics problems already. So some examples. For example, like undersea navigation. Startups are applying it for undersea navigation, collection of plastic trash in the sea. These all, again, involves mechanical engineers, people with chemical engineering background, people with electrical engineering background, machine learning people. So machine learning is not the only component. You have many components coming together. Question is, what area do you want to specialize in? Another very simple example that we see today are iPhones, iPhone applications. The apps that iPhone actually, or Apple invented. These use sensors and software. So essentially, you can think of them as robotics applications that are solving various problems. An example, the Humpy Planner in India, it can actually provide itinerary recommendations if you visit Humpy. And in space, so for space exploration, they've also been traditionally used. Why are robots still dumb? Do we know that they're still dumb in certain areas? Why do we think they're dumb? That is because many of the solutions that exist today in AI are not explainable, in the sense these models, especially an overwhelming set of the black box methods that we call, which get tied to deep learning, they necessarily need not always be deep learning. They cannot really explain why they're making decisions the way they do. Which means, let's say you've built a robot that can navigate through the best roads and deliver something to the restaurant, or deliver a dish from the restaurant to you. And it needs to go through the best route that is not really busy. So how could it might actually do the task, but it might not be able to tell you why it chose a certain street. It is the only reason given is because the model predicted so. And the accuracy is explaining to you that overall certain times have been shorter, or that you could always collect metrics post the result, but you cannot. These robots are not really capable of telling why they made the decisions the way they do. So is there a way, the question comes around, is there a way to understand why it behaves the way they do? Could these applications, when applied to robots, enable them to explain the reasons behind their actions? So that's a question that has to be answered. And we are looking at something called as explainable AI, which means, in machine learning, a classical branch, it's called probabilistic machine learning. This is a very promising area because some of them are deep learning and some of them are not. An overwhelming part of them are non-deep learning methods. And these are something called generative methods as well. They can actually explain causality, which means if a restaurant is busy, then you could explain as to why it is busy and what could be the reasons why a certain route is busy or not busy. Is there a game going on nearby? Is there an event going on nearby where people have gathered? That could be the reason. And what was the real reason behind an event or a result? So these kinds of questions can be explained to some extent by the causal models or explainable models. And the advances in this area are still happening, and this is an open area of research. So now I'll talk to you about explainable AI. So if we are looking at some of these traditional methods, then you're looking at graphical models. So an example is a graphical model. A graphical model, essentially what it can do is it can identify anomalies. For example, if you have restaurant bookings that have to be if you have to design an application that has to do restaurant bookings, then what are the events that can cause or affect the restaurant bookings? One is the traffic, and the other is a new dish, let's say, has been introduced in the restaurant. And the new dish can actually spark an interest, and people might end up going there to have that particular dish. And an example here is that the traffic itself can have other factors that affect it. For example, there could be an accident on the road that can lead to high traffic, or a game going on which could lead to high traffic, or even low traffic if there is a weather or rain going on. So these are different ways. And then, do you want to travel through the pedestrian or walk path, or do you want to travel through the car? So these are different events again. And then if you're walking through, then the event being sunny or rain can also affect your walkway. So these are questions that we should ask ourselves, and then we can always model them in terms of a graphical model. We can assign probabilities to it, and once we assign probabilities to it, we can actually explain how much component of a certain cause has led to that particular event. Like how much amount of the event called sunny, the day being sunny, can lead to people walking on the street, or if it rains, does it reduce? So these are questions we can answer using these models. So probabilistic inference, which means at the end, you could always, if the traffic is observed, knowing that the road was clear, and let's say the game is also not happening that day, can you infer what the restaurant bookings will be? Like how much of traffic will the restaurant get, for example? So these are questions you can answer using these explainable models. So there are many areas where you could, and here is an example where PGMPI is a software that's available online. You could go online, and then you could start using the model to get inferences from. So there are many packages available online. This is one package called PGMPI, and PGMplot is a way to plot these examples. So these are available online. You could go and you could download and you can experiment with them. It's on GitHub. So case studies, for example, let's say you build a fraud model. Like what's a fraud model exactly? So let's say there has been a purchase of a jewelry on a credit card transaction. And can you tell if that particular transaction where a person bought jewelry or gas, was actually a fraudulent event or not. Like, how do you flag an event as a fraud? Can you build a system that can actually flag it as a fraud? So, which means that you can look at probabilities of fraud that have occurred in the past, and then you can tell how many times. So, the reason this particular model is talking about how many people are likely to commit fraud. Given that if we take all males and all females, and then if you look at the age in which they commit fraud, and leading to, let's say, somebody steals a jewelry and runs from that particular scene, then usually what they do is when they buy jewelry, they also buy gas because they want to flee the scene as far as possible. So if you see transactions happening in jewelry and gas, to some extent, you can always tell that the probability that of this transaction being a fraud is high. But for that, you also need to account for what is the historical probability of fraud, what is the historical probability of age groups and the sex committing these frauds. I mean, most frauds are like, let's say, are done by males, for example, in a certain area. Then you can always count those numbers and then come up with an inference saying, look, most males commit jewelry fraud. And so it is most likely, given that it's a male, given that the person is of a certain age, let's say between 20 and 30, and the person also bought gas while buying jewelry immediately, or we can infer that it was a fraudulent transaction. So these are examples by which you could alert users on fraudulent data when the credit card gets stolen and gets used. And you could also come up with credit risk models, like, what is the rating? This is very common. People with credit cards usually have these ratings, like, A and B, which means that you have a good credit, good spending history, or, are you under the high risk of giving loan to you where you don't pay it off, or do you fall under the low risk? So you could actually model that using these causal models. There are other examples. Let's say you want to link many databases together. You have many databases that you want to link them together, and you want to get inferences from. But you don't have a common ID to link them between these databases. Then essentially you could come up with a way where you can actually link many of these databases together using AI. You can use natural language processing methods that can actually predict if two addresses are similar to each other or two names are similar to each other. So yeah, so that's I want to restrict my talk to just that time and then leave some time for the talks or questions. Can you hear me all? Yes. So any questions so far? Feel free to ask.
Thank you so much, sir, for such an insightful talk. Let's begin with the Q&A session now. Sir, we know that the day is not far when we will have artificially intelligent humanoid robots around us, maybe even as our domestic servants. So, what do you think that should AI robots have their own rights? Like, because they can feel, do we count them as living creatures, sort of?
So that's a very good question. My answer to that is different. Different people could give you different answers. I think that if you define what ego is, then I think you're looking at that problem. To answer what ego is gets into a philosophical debate as well. So you'll have to really look at how do you define ego. Like, one example is self-protection. Like, do robots have the ability to protect themselves seeing a danger, which living beings can? Can we design it? Yes, we can. And then can we build certain growth? For example, humans want to grow into certain areas. They want to progress into certain areas. Can we bring those natures into robots? So if we are making robots learn all those qualities of what really defines a human as such, or even an animal as such, then I think we can get closer to that answer. But in terms of distinguishing what a human is versus a robot is, that's a tough question. I don't have an answer to that yet. All I can say is, I believe that they're the same? No, I believe that humans have consciousness and they have the souls or the atmas that we talk about. So I personally don't believe that they're the same.
Okay, thank you, sir. That clears it up. So we have our next question. How can we pursue in the field of ML, AI, and data science?
So the most important is at this level in undergrad is to study the required basics. That's very important. The theory has to be in place, which means you should be studying linear algebra, probability, and then differential equations. Get all the mathematics necessary to understand the language of machine learning. If you're looking at data science, you may not need all these methods. Data science, you're really looking at coding. If you can learn coding to some extent and then take some courses that are built on top of applied machine learning models, without knowing exactly how they work, they're easier, definitely.
So, sir,
And
what do you think about the
problem and
future
solve.
of?
Pick a problem and solve with work at a startup or a large company, wherever, but pick up a problem and solve during your engineering. That gives you a lot of insights into what you're trying to do.
So, what
So
do you
I
think
have
about
a
the future of?
question. I have a question. I came to know like you were you started the Alexa program.
No, I
So
didn't start the Alexa program. I
I
was in the
came to know
team
on
that
the
was,
internet.
I was in the team that was hired from BBN, was hired by Amazon to start the Alexa program. I worked in the same team. My advisor was the one who was formative in starting it.
So do you gain any experience over there, and how was your experience?
So yeah, so prior to Alexa, I was in this research lab called BBN, and the experience was amazing there in terms of being able to understand this. These were being applied to Arabic scripts, and speech recognition was applied to Arabic for defense programs, essentially. And they were really extremely sophisticated machines prior to deep learning, which means I had to work on large supercomputers to make this work, and it was amazing. It was all on the Al Jazeera news broadcast that we had to apply our algorithm. So,
So
Sir,
the
what are your
question
thoughts?
is, what are your thoughts on great debate of AI taking jobs?
it, I think it will happen. I think it will take on certain jobs which are routine, which it's like this classical example that is being spoken about in this industry is the steam engine, right? I mean, when steam engine came, people thought that the horse cart will all go away. People will not stop using it's an automated machine as such. It did reduce for sure. People started using more vehicles for sure than horse carts, but do people still use horse carts? They do. So it will take off some jobs. Certainly there are certain jobs that are routine, like testing, for example. Software testing, I think, will be taken away very quickly.
So, what do you suggest as a starting point for a beginner who's just starting out with ML?
So yes, so as I said, the courses are one, and the second thing to do is solve one problem in machine learning. Like, work at a startup or work at a company that does solve a real problem in machine learning, and then be a part of it. You learn a lot while you solve and you study the theory both.
Sir, I have a question. Like you said, robots, if AI can replace in the future, can they replace the doctors? Because we can't let a machine do an eye surgery for us. We can't
Well,
believe on a machine doing such
that's a
surgery.
very, very good question. So the reason why you're afraid of a machine doing surgery versus a human, can you tell me?
So we have little bit faith on humans,
Correct.
but we can't faith robot
Put faith on a
or
robot. The
like
reason is
a
because of accuracy levels.
yes.
Let's say you operated on a monkey, on a
Okay.
monkey's eye, okay? Maybe 10,000 monkeys. And let's say you divided 10,000 monkeys into 5,000 and 5,000. And 5,000 monkeys were operated by humans and 5,000 by robots. And out of 5,000 humans, let's say 10 monkeys, or maybe let's say 100 monkeys lost their eye. Okay.
Okay.
And let's say with robots, it was only 10 monkeys that lost their eye. Then would you go to a robot or would you go to a human?
because we can't take an objection here where we can't get the information from the monkey whether they are believing on the robot or not. But we can take the advices from the human that
Correct.
they can believe or not.
Yes, exactly. Explainability, right? So you won't know why certain decisions were taken the way they are as of now. So if you are able to solve that problem, and if you're able to solve the levels of accuracies where you could reach much better accuracy, you might as well go for a machine than you go for a human. So I think it all depends on getting the confidence. Now the confidence is not there because they are known to be dumb. If
Yes.
they can explain their actions, A, and B is if they can actually, even if the explanation is not there, if they can meet the levels of accuracy, beat the levels of accuracies of humans, you would trust a robot more than you trust a human.
Yes. Uh,
Sir, what do you
yes.
think about the future of ML in India?
I think it is great. I think the youth in India are very energetic. I think people, they study on their own. They're very motivated. Given that, I think that we'll be. I see a lot of promise in India, not only for in terms of people picking up the level of AI, but also in India as a client as well. I mean, in the sense, India having people requiring the need or getting into the field of AI as well.
So a question from my side. AI needs a lot of data. What are thoughts on privacy issues in this data-driven world?
It is definitely a concern. So you that's it's it AI. Yes, generally not all models in AI need a lot of data. There are some models called unsupervised models. You can look it up. Those literally need zero data to make inferences from.
Yes. Yes, sir.
So, but let's say overwhelming, it's a fact that overwhelming models do require large amounts of data. So, if you require large amounts of data, then definitely the privacy issue becomes a concern because your privacy issue is being, your data is taken to make inferences from. But there are ways you can solve that. Let's say that you're supposed to be, you're supposed to perform a certain act, which is humiliating in the real world, right? What if I cover your face? And nobody knows who you are, but you're still performing a humiliating act in the real world. It
Nobody
doesn't,
knows.
right? So that is very similar example that I give in terms of, let's say you're asked to dance in college. Somebody writes you and tells you to dance, and gives you a piece of paper to cover anywhere you want. Would you cover your face? If you cover your face, nobody knows who you are if you danced. People know that
Yes.
somebody danced, but they won't know who danced.
Who does?
So that's the whole idea here is in similar in AI. If you mask the name and the address, but you revealed everything else about the person, there are ways you can mask their identity because the data still exists, but you won't know to whom it belongs.
Yes. Yes.
Sir, how is the current scenario of research in AIoT?
Yes, so robotics in general deals with sensors, hardware, and software, right? So IoT is definitely very promising because you gather data from stuff around you in certain ways. So IoT is essentially a way to collect data in different means or different ways using sensors. So AI on top of IoT is definitely an application that is great. But as students, you could be motivated towards that and solve a problem using that. But at the end of the day, you should know that the theory behind an IoT versus a different application is the same theory of AI, same theory of robotics. At your age, you should be focusing on that than just looking at the application of IoT. They're the fancier ones. They're motivating, surely. You could do it as a problem or a solution. You can solve it as a problem and come up with a solution using any of these methods. But it's very important at this age is to focus on the basics.
Okay. Sir, a question from my side. Will data science be fully automated in future and job opportunities will decrease?
Some level it does get automated. Not that it'll get fully automated. To some levels, yes, it will. But I don't think it'll get fully automated because dimensions of problems are very unique. And if you have an automation system, I do not believe that you can solve every problem that exists out there. And so I believe that that particular area where data science itself will get automated, I do not believe that it will happen to a large extent, because the problem space is very unique.
Yes, sir. I
Sir,
fully accept.
what do you think about the application of ML in the banking sector? How can it help prevent
Well,
transaction frauds?
yes, absolutely. So let's say that you're trying to avail a loan, right? And if the data
Right.
about you from Aadhaar is linked, then that itself shows anomalies of you having not paid your loans in the past. So would bank give you the loan? So
No, it
that's
won't.
an example. So this is an example of how just data analytics can predict, given that your history of payments can actually predict and say, look, I will give you or not give you the loan, essentially. Or you've had a tendency to commit a crime or any of these things. So these are ways in which, but that's only one example I'm giving you. Another example is forms. Very simple. ML in banking is huge. For example, let's say you have these forms where people go and fill out for applications. It's still done by humans today. So one of the ways where ML can really make an impact, which you might not have even thought of, is pre-filling these forms. If you pre-fill these forms, it saves time and you have more customers in a month. So the amount of penetration of AI into all of these fields, especially like banking, is huge. Even data, for example, let's say you want to bring all the data to a common place. You don't have many names and fields that match with each other. For example, your insurance being held in one place is not always linked to your bank accounts. If you just link them together, when there's no ID using NLP methods, that itself will bring a mine of information.
So one question, like Uber made a car, automated car that can go on the road without any driver, and due to some errors, it just killed a person because of some error, maybe some data error or anything. Tesla also launched the same car.
That's right.
Can we just allow the car to roam over the road? Because in India, if we just say, take
Yeah.
an example of India, we
Yeah.
can't let a car go and roam here and there.
Yes.
And it's all about AI and machine learning behind these automatic cars.
Yes.
So, what can you say about that?
I think the if you're asking that it should be allowed, I don't think it should be allowed on the road. But in spite, once you see certain levels of accuracies, people do allow on the road. But then there are these edge cases. What Tesla failed was an edge case where there was another truck that was white in color and it confused itself to the background, and so that was the reason of the crash that happened. So certainly one has to be cautious when one gets onto the auto driving mode. So auto driving mode, I would not trust as of today. I mean, in high speeds, I would not trust. In low speeds, I would, because in low speeds, what happens, right? Maximum, if there are all other cars, at very low speeds, you should be able to, even with an accident, it won't be fatal as such. So in those, it's a question of risk reward analysis. And so in India, for example, I think if you can make something work in India, it'll work anywhere in the world. I mean, with all the cows being trained, and then for all the dogs and everything, I mean, it would be amazing if you can solve it for that.
And sir, what about problems like hacking? Like if there is an autonomous car or an artificial intelligent robot, if someone hacks it and makes it do stuff that is not wanted,
Yeah,
and it can well become a nightmare.
it can, and I think it will be done because cyber security is another important area that is coming up, where even AI is making heads into it. So the way people can actually hack into these robots can be a risk, and it will exist. People will try to hack into these systems and control them. That's a fact.
Sir, a question came up from the viewer that how can we convince the people to trust AI?
Trust AI.
Yes, sir.
So yes, to trust AI is the impact. If you see an impact that matches levels of your desired expectations, then you can trust AI. So one way is there are multiple ways you can build the trust. Let's say you have humans doing a certain task, you introduce it only 10% in the entire space. Okay, so let's say you take autonomous vehicles, you only introduce 10% of them in a certain space, and you see how they work. Then you increase the percentage of absorption, and then over a period of time, if you see that the number of vehicles on the road are performing well, then using AI, then you can actually trust it, given the data. The impact decides it all.
So here's one more question. Like we got to know the driver is not, you will not be believing on the autonomous cars. Then, in case someone have an accident, then who will be held responsible for that? Will the maker who made that data analytics about machine learning, or the owner?
I think that's a very good question. First is that the people who deployed it on the road, the company that deployed it on the road should be held accountable for the mistakes that they do. I don't think the person itself, but the company that deployed it should be held accountable for the mistakes that they do. And then the other thing is also you need to look. This is assuming that the robot or the autonomous vehicle failed in its task. So how do you define fail? Question is, was it the mistake of the person who hit the vehicle deliberately, or was it the mistake of the robot? I think that if we are able to solve, then the question comes down to how do we solve it? And certainly, it's not going to be an easy fix. I mean, we'll have to come up with a sophisticated way to deploy them into production while minimizing the damage. But you should also look at the value that it brings to the real world as well. When you penalize or hold them accountable, you should also look at what the issue was. Was the resulting accident fatal, or was it a minor issue? How did it mitigate the analysis? So when an accident occurs, already cars without any, forget the autonomous vehicles, the existing vehicles have ways to recover from the accident. So when an accident happens, these vehicles, the internal engines actually collapse into certain situations where they do not cause much damage. Already those in regular engineering processes are in place. With AI, that becomes even more important.
It's,
Sir, as ML brings machines closer to being humans, can emotions be added to the machines as well?
Yeah, you can, right? I mean, you could fake the emotions. I don't think you can add emotions. You can fake the emotions because the consciousness doesn't exist. There's no consciousness in the robots. Like we are all the four of us are conscious here. While we
yes.
behave, we are conscious. The consciousness is not existing as of now. Now the question comes down to what do you define consciousness as? So consciousness is being linked to emotions. So you can add emotions, but adding emotions, these are fake emotions. These fake emotions, do they bring consciousness? I do not think they do.
Sir, can machine learning programs or artificial intelligence ever replace the judiciary system? Like, can it ever judge a case and decide the criminal, or like decide
Uh,
laws?
as of not only now, even historically before AI, probabilistic methods have been used to come to decisions. What is the probability of a person having committed the crime? Has been used earlier. Statistical methods have been used earlier. I do not think that AI itself will be used to the point of using, becoming a judge, but I do think AI methods will help augment a judge in making decisions. Like detection of a fake video versus real video is an example. People can doctor a video these days using a deep
Yes,
fake
yes,
and make the
yes.
person having committed a crime. But if you can detect that it's a fake video with a very high precision, then AI can help remove and say that it was a doctored video.
And sir, deepfake itself is it's a gift of machine learning and deep learning. So, what would you like to tell about deepfakes? Is it a problem? Is it a threat?
Deep fake is it? You said or deep face?
Yes.
So what? Can you repeat the question again? Sorry.
Like deepfakes exist because of machine learning and artificial intelligence and deep learning. So, do you think is it a threat, or there can be a
Yeah,
potential
for
use out
sure.
of
Oh,
it?
yeah, they're definitely threat. I mean, you can make Barack Obama dance now. I mean, come on, it is definitely a threat.
Yes.
So there is a one question. Why there are still very less jobs opportunities as a fresher in data science compared to developing side?
Sorry, I see the Harshvardhan's question different from
Okay.
you.
let me ask this one only. LiDAR sensor is better
Better
or
or
Tesla
Tesla?
technology, which consists
Okay.
of combination of camera and sensor is
It
better?
depends on if you're a fan of Elon Musk or not. I'm a fan of Elon Musk. I do believe that what he says is mostly right, sometimes most often than not. But it really he might have more information than others in terms of lidar not being great. So I don't know the answer to that.
So we must be calling Elon Musk in the next talk.
Yeah, sure, go for it. Yeah.
Okay. So a question. I saw somewhere that if we upload same data again and again, its quality gets changed, like video and audio. What if this happens with AI?
In the sense, I didn't understand this question. If you add more and
Uh,
more data, it becomes bad. Why so? Or is it because of overfitting you're talking about? I don't understand.
it can be like, sir, if we are just sending a data, the data's quality decreases. That may
Yeah,
be
data
possible that
quality
the
decrease.
accuracy to judge the data will also decrease by the machine.
Yeah, it can certainly. Yeah, in short, it can. But there are ways in which you could mitigate it.
So one more question from my side, please. Why there are still very less job opportunities as a fresher in data science
Yes.
compared to developing side?
Yes. Yeah, I mean, it will. I think that will be the tradition, if you ask me, because software development in general is going to be the way you get to the real world. And data science causes a lot of impact and can only be done by few people as well today. And also, the software has not reached levels of automation where data scientists or machine learning people are needed to automate these methods. So, if it's a transforming field. The number of opportunities are there, but it will not be as much as. So, even for example, if you take a machine learning project to be solved, usually if you have 2 to 3 machine learning people, you'll have 4 times that of software engineers. So your opportunities for software will be far more. As of today, at least it is far more, because you need somebody to bring these models into production, into the real world, which is also interesting. Is also fun, and that's a lot of work. That's a lot of work in terms of. Is it tougher than machine learning? No, machine learning is tougher task for sure. There is a hierarchy there for sure.
Seems tough for me as well. To see the stats
It is tough
is
because
horrible.
it's tough as long as the language of machine learning that it's written in is you're away from it. If you start looking at learning those mathematics, then I think it becomes easier.
I have an interest in mathematics, but still, machine learning hopes to be like something horrifying. I don't know why.
Yeah, I mean, it's also because of the overwhelming breadth and the depth, right? So, what do you think is the best advice for us to kickstart our journey in this field? Most important is take courses. Take linear algebra course, take probability course, take the differential equations. Do your undergrad math properly. Work at a startup and solve a problem. I mean, in the sense, do an internship. Do internships during your school. That will help a lot of you to get clarity into what the work is going on in the industry and how it relates to your subjects.
Okay. Anyone else for the questions? Let me see some. Do you think it is really wise to invest extensively in AI? Don't you think maybe we would one day make a Terminator?
Yeah, maybe possible. Maybe you want a Terminator.
So, if you don't mind, can I know on which project are you working on right now?
No, I'm not allowed.
Anything?
I'm not allowed to say that, unfortunately.
Acha, what was your
It's
last
due to
project?
IP. Yeah. So last project that I was involved in was involving identifying objects, essentially multiple objects. Using computer vision,
Okay, by using
object
OpenCV.
detection task,
Yeah.
and also about hardware robots in general, using AI into hardware robots. Those were the two broad areas I was involved.
Okay.
Sir, if you have to
Uh,
describe your journey so far in just 3 words, which 3 words would that be?
Just follow your passion, enjoy it. Do not worry about the money.
Nice.
Sir, there is a question. How is robotic process automation related to machine learning?
So it is because you have certain sets of tasks where there are patterns in which they're executed. You can learn those patterns using machine learning and automate them.
Sir, I've just learned like unsupervised learning and supervised learning. Unsupervised learning is like we have not given any data over the machine, and supervised learning we are giving the data. So the unsupervised learning will make a lot of chaos. Then we are not giving any data to it. Then
No, not necessarily. No, not necessarily. It depends on your application. For example, clustering is very useful tool that works without any, there are unsupervised clustering methods. Those can give you inferences to a very reliable way without any training data. So it's not really like that.
that's-
Any other questions? You can always reach out to me through email. That's probably the best. You can email me and reach out to me.
okay. I think sir, we have ended with the questions over the views and the chats. Thank you so much, sir, for such an
Thank you.
inspirational, informational talk.
Yeah, you guys are doing a good stuff here. Be motivated for sure. It's very good. That's one of the general advice as well. Somebody was asking, what's the general advice for sure? Be motivated, follow your passion. Taranam is very passionate. Be like her.
Thank you so much, sir. We will follow her definitely.
Sir, we sincerely hope to see you again in one of our future talks.
Sure. Thank you. Thanks for inviting me.
We extend our gratitude to you, sir, for giving your precious time for this Global Week 2021. Thank you
Sure.
so much.
Thank you.
Thank you, sir. Thank you for joining us.
Thank you.
Bye, sir.